All right, so in this lesson, we're going to be talking about using scientific notation to describe very large quantities. So the whole point of scientific notation is so that we're not writing these giant numbers. And so science is which is part of the reason why it's called scientific notation. Science uses scientific notation a lot because and we're going to see some examples of it, but like to tell the distance from between planets, or from the Earth to the sun, or the Earth to a different planet, or to stars, or no one wants to write the amount of zeros that goes between. And so that's what scientific notation allows, is for us to shorten that up. It's kind of like when we were talking about multiplication being the fact that mathematicians didn't want to write repeated addition, and that then from there exponents became a thing because we didn't want to write repeated multiplication because we're like, oh, this is ridiculous. I'm just multiplying the same number. There's got to be a way to show this so that I don't have to write these giant expressions. Well, it's the same thing with scientific notation. Mathematicians and scientists, because they use a lot of math, said, I don't want to write all of these numbers. Let's find an easier way to write that. So that's where scientific notation comes from and why it's used. Now we're going to use it today to describe very large quantities. So when we're expressing numbers in large quantities, that, and this is a fairly small number comparatively, but here we have 384,000. And I know that my decimal is over here. And if we remember what we discussed in the last section about scientific notation, we know that we need to move that decimal to where it is between, or where my number is greater than or equal to 1, but less than 10, meaning the digit in front of my decimal has to be between 1 and 9. So that means I need to move my decimal to where it is between 3 and 8. And so I'm just going to write, and you only write the numbers. We're not going to write, remember, we're trying to make it to where we're not writing as much. So we're just going to write 3.84, and then we know we're always going to have times 10, and from there I just move this decimal. I'm going to count 1, maybe if it'll stop. 1, 2, 3, 4, 5 moves in order to get it between the 3 and the 8. And so I put next to, or in my exponent, a 5. Because that's how many times I moved my decimal. 1, 2, 3, 4, 5. And then now it's in scientific notation. And yes, it's as simple as that. So, talking about examples, here we have 1 astronomical unit, which we'll refer to as AU from here on, is the average distance between the Earth and the Sun. And it is approximately 93 million miles. We want to express that in scientific notation. So, first, we've got to keep in mind how much a million is, right? So sorry, I got sidetracked. All right, so you got to remember how many zeros a million has, which is 6. So when I write this, I would have 93 and 6 zeros. So that's our original number. Now we want to express it in scientific notation, which means I need to take my decimal, which is here at the end, and move it 1, 2, 3, 4, 5, 6, 7 places. So that's 7 moves. to get it between the 9 and the 3. And so 9.3. So this is a good example of the fact that when I say between 1 and 9, I'm really just talking about this digit here, that this digit in front of the decimal is between 1 and 9. Technically, this is still going to be scientific notation because the true definition told us that our number had to be greater than or equal to 1 and less than 10, and 9.3 is less than 10. So I just want to point that out. But here we have 9.3, and we always do times 10. And then we count it, and we're going to count it again. 1, 2, 3, 4, 5, 6, 7 decimal moves. So that's the number that goes on top. Bada bing, bada boom. And there is my scientific notation. That is it for this video. In the next video, we're going to talk about, well, how do you get it from scientific notation to standard form? So we'll see you there.